Alright, welcome back to Diesel Talk. There's Beto putting back together a 6-liter, working on that. But that's a separate story there, so we'll come around over here. And we got a 6.4 liter, excuse the wind. We got a 6.4 liter we're looking at here. This one's got oil leak around the turbos, so we're definitely going to do the turbos on that also. We got a fuel rail pressure issue, so we're going to come around here and we're going to go ahead and take a look at this, maybe see what's going on with the turn key on. We fire this thing up. It does run, yes, but you'll notice we got a check engine light and it's been having intermittent stalling issues, so we're going to take a look at it over here with our IDS. So let's get started here. Okay, just to show you what came up on the scan tool, I thought I'd do a screen record for you just to look at here. We're going to go ahead and hit play here. What you're going to see here is we have the code P2289, which is ICP too high. Now, obviously, what we're going to do is we're going to verify what the rail pressures are doing, but we're in for a little surprise here. Now, IDS allows me to do, as you can see here, a high rail pressure test. Now, as I'm discussing and we're showing the test being done, you're going to notice it goes in increments. 5,000, look to the left. You're going to see 5,000, 10,000, 15,000, 20,000, even up to 25,000. So we're doing the first stage 1 test, which is up to 5,000 PSI. You're not going to be precisely right at 5,000, but you're going to come real damn close, which is 4988. Now, if you look over here, you're going to see there is a plus or minus. In other words, a range it could be within, plus or minus 290 PSI. We're well within that, and that's what you want to do. You want to be really close to it, and that's what we're looking at. So we continue to see the rail pressure test going up, but as this test continues, there's something not good about this. What's not good about this is, and that's what I teach technicians when I train technicians, is that this is a static test. What do I mean by static? At rest. There's no engine load on there. So in other words, you're not simulating pulling 10, 15, 20,000 pounds behind the truck. So this is a static test just to see if you build pressure. But if you don't confirm the lift pump pressure coming into the system, this is the high pressure side, right? So we need to have between somewhere around 6 to 9 psi of low lift pump pressure. So we got to verify that too. But my problem is I see pressure high, so I'm inferring that the lift pump pressure is okay. I'll double check it, but still, I'm inferring it's okay. So that means something needs to regulate. So as we look here and it's finishing up the test, please note, let me pause it here for a minute. Please note here that we got the 2 key players we're going to show you real quick, the VCV and the PCV, better known as the pressure control valve and the volume control valve. Now, I will show you the 2 actually on the injection pump. So sadly, the PCV, pressure control valve, and the volume control valve, which controls your rail pressure, as you're going down the road, as you're driving, as you fire it up, whatever, that is controlled by the computer to regulate the rail pressure. So as you see these rail pressures go up and down and stuff, you got to remember who's doing it. The PCV and the VCV, both located on the injection pump. So overall, we see that everything has passed and we're working just great. So in the long run, yeah, you can use this to see if it's got a problem at idle speed, but the best way to test the rail pressure is to take it for a test drive and observe the desired commanded pressure and the actual rail pressure. So let's move on. Okay, what we're seeing now is the another way of looking at it. Like I said, you want to take the vehicle under a load to see what's going on. So what I'm selecting is the bar graph. And as we look at the bar graphs, we can see over here our desired rail pressure, and we see our actual rail pressure. So we also want to look at fuel rail pressure voltage. Now, this was a challenge because yesterday when I first scanned this truck as it came in late, I actually saw 3 volts and it was locked in at 3 volts. And you'll notice these numbers are always changing. And what happened yesterday is these numbers were fixed at 5,076 PSI. Now it's all varying, which is indicative either I got a rail pressure issue or I got a sensor issue. So definitely the PCV VCV is the problem, but again, they're housed on the injection pump. But what I'm merely trying to show you is you always compare the desired rail pressure, which we see here, and we see the actual rail pressure. So their best diagnosis is to confirm that, provided again, I know I'm repeating myself, that you have checked lift pump pressure. So therefore the voltage changes. There have been situations on trucks where the fuel rail pressure sensor voltage is fixed. You can see it changing right here. So in this case, it can stay fixed. If it's fixed, that's a big red flag. So like I said, yesterday it was stuck at 3.2 volts roughly, and it wouldn't change. But it was jumping up to 3.9 a little bit, but now you can see it operating normally. So something you got to keep in mind is to know what your voltages should be like and how they should look at. So there you go.
All right, as we go ahead and look at the injection pump, we got another injection pump here that's going to go in this truck. This is a Ford Reman unit. And what we're going to see here on the injection pump, which is like this, obviously the gear's missing. Those of you who've never done a pump, that bolt that goes in the center, that actually is reverse thread, but you got to follow the instructions. So one of the things you're going to see here on the pump, we see 4 lines on the top here, and that is our low pressure lift pump fuel coming in and our return, and our 2 high pressure lines right there. So that's what we're talking about right there. So over here on the side, let me lay this down here so you can see it. That is our VCV. That's our volume control valve. That's controlling the volume of fuel coming in, while the fat guy on the other side, let's see, the big solenoid right here, sorry, you're going to see the PCV here. So this is a pressure control valve. The other one that I just showed you is the volume control valve. So the problem with this setup on a Powerstroke 6.4 is if any of these have a problem, either the VCV or PCV, you have to get the whole injection pump. So therefore the whole injection pump. And to get to that injection pump, turbo's got to come out, some people do cab off. It's just a pain in the butt. We're talking about major labor to get to it. So it's sitting underneath the turbocharger. Maybe I'll put a picture of one real quickly for you so you can see where it's at. But this is the injection pump. So it's all in one unit. I mean, the intention would have been good if it was more accessible. But unfortunately, the VCV, the PCV, the injection pump, everything on the Siemens pump is located all in one unit. So if any of these have a problem, like this, again, there's your PCV, you're going to have to go ahead and replace the whole unit. You cannot buy a PCV, you cannot buy a VCV by itself. It's not available. So what do you got to do? Replace the whole injection pump. So what do we got here with this truck? We probably have a VCV or a PCV problem. We're not regulating pressure. That's why it sits at high. From my experience, it has been the PCV the problem, but I couldn't verify that for sure. Now, the last thing is there's going to be a wiring harness going to it. I'll try to show it here on the truck. As a matter of fact, let's walk over back to the truck, and you're going to see there's a harness that comes over here. And that harness is located down there. I can't reach it, but it's right there. It's on the base of the injection pump. So there you can see the low pressure turbo. That's your low pressure turbo. Over there's your high pressure turbo right there, one with the shiny shield. But we're gonna see a harness right here, and it's a 4-connector harness. And what we can do is we can disconnect it, and that actually feeds power to the VCV and PCV, and the ECM controls to control it. So I often have disconnected in the past. That connector goes down here, and we've been able to see if we got a leak too. In other words, the PCV is normally open, the VCV is normally closed. So should the engine even try to run when you crank the engine if you disconnect that harness? No, it shouldn't. And if it does, or wants to even act like it's running, then therefore you know you got a bad PCV or VCV stuck. So something to keep in mind there. Most likely the PCV. But anyways, there you go. So therefore that injection pump is buried under the turbos here. So we got 2 turbos, in case you didn't know, on a 6.4. Again, our low pressure turbo, high pressure turbo connected all in series. So it's located under there. So to get this puppy out, you're talking about some serious labor just to get to it. So this is Beto's new job coming up after he gets done with that 6.0 to get this turbo out. We're not going to do a cab off on this one. I'll try to share pictures on another video coming up.